Good morning, everyone. Myself, Monica Nancy Priya, working as assistant professor in the Department of Electrical and Electronics Engineering in the semester handling W3017 embedded C programming in the regulation 2021. In today's video, we are going to learn about 8051 microcontroller, its history, pin description, and some important control pins. This topic is very important for both theory exams and lab understanding. First, let us start with the history of 8051 microcontroller. In the year 1981, Intel introduced the 8051, which is an 8-bit microcontroller. When I say 8-bit, it means the CPU can process only 8 bits of data at a time. The microcontroller is also called a system on chip because everything is available inside on IC. CPU, RAM, ROM, timers, serial port, and input-output ports. Inside the basic 8051, we have 128 bytes of RAM, 4 KB of on-chip ROM, two timers, one serial communication port, four input-output ports, six interrupt sources. So the 8051 is the complete mini computer on a single chip. Next one is the 8051 microcontroller family. Not all 8051 chips are exactly the same. 8052 is an enhanced version of with more RAM and an extra timer. And 8031 is also called a ROM-less microcontroller. This means the 8031 does not have internal program memory. So we must connect external ROM to store the program. This distinction is very important for understanding later pins like EA and PSEN, etc. Then the various 8051 microcontrollers over time, many companies manufacture their own versions of 8051. For example, 8751 is an EPROM based version. And 8089C51 from Atmel is very popular in labs. In our labs, in embedded C programming, also we are using 8089C51 for blinking of LED, flashing of LED. We are using this Atmel Corporation only, this chip only, DS89C4X0 and DS5000 are high-speed versions from Dallas Semiconductor. Some versions are OTP, meaning that we programmed only once. So the 8051 is not a single chip, it is a family of microcontrollers. Then it is a block diagram of microprocessor and microcontroller. In this, we are having arithmetic and logic is both in the micro present both in the microprocessor and microcontroller registers, program counter, stack pointer, interrupt circuit, clock circuit. These are all common for the microprocessor and microcontroller. The only thing is the RAM and ROM and the timer and counter. These are the important for the microcontroller, which is extended version of the microprocessor. Then 8051 pin description. Let us understand the physical structure of the 8051. Most 8051 controllers come in the 40 pin package. Each pin has a specific function such as input, output, address, data, read and write control, interrupts. Some manufacturers also provide 20 pin versions for the smaller application. This is the pin diagram. This is having ports P1, P2, P3, input port, output port. This is the ADC, AD timer, and the XJAL1. This is the timers, clockers, and interrupts, receivers, transmitters. These are all in the 8051 microcontroller in the AT Atmel Corporation, 8089C51. Next one is XTAL1 and XTAL2. Now let's talk about the clock, which is the heart of the microcontroller. The 8051 has a internal oscillator circuit, but it needs an external crystal to work. We connect a quartz crystal between XTAL1, that is pin 19, and pin 18, that is XTAL1 and XTAL2. Along with the crystal, we connect two capacitors, usually of 30 picofarads. This crystal decides how fast the microcontroller runs. For example, if you use 12 picofarad crystal, 12 megahertz crystal, the microcontroller runs at that speed. You can even observe the clock signal at XTAL2 using an oscilloscope. This is the oscilloscope. We can be observe the clock signal XTAL2 in the in the external oscillator. If instead of a crystal we use the TTL oscillator, then we can connect it only to an XTAL1 and leave that XTAL2 as a unconnected. This method is used in some industrial system. The oscillator which is connected in only one clock signal XTAL1 and leave the XTAL2 as it is. That is the no change in the pin of XTAL2. Next one is the RST. What does mean by RST? That is the reset. Yes, now discuss about the reset pin, which is very important. Reset is the active high pin. Normally it stays low. When we apply a high pulse, the microcontroller stops all operation, clears all registers, and start execution from the beginning. That is the name for reset. Whatever the system, whatever the program is undergoing, whatever the system is running, that is not a point. If we click the reset button, it stays low. We apply a high pulse of the microcontroller. It stops all the operation and clear all the registers, start execution from the beginning. This is called the power on reset. The reset button has a high power, so high pulse. Important point for exam is the reset signal must be high for at least 2 machine cycles. If it is shorter than that, reset will not work properly. Okay. The next one. This is this is the reset pin which is connected to the XTAL1, the oscilloscope which is connected in between the X1 and X2, that is XTAL1 and XTAL2. So the reset pin which is highly high for only for the 2 machine cycles. Then is EA, external access pin. The EA stands for the external access. This pin tells the microcontroller where the program memory is located. If EA is connected to VCC, if EA is connected to VCC, then the program is taken for internal ROM. Then if EA is connected to the ground, the program is taken for the external ROM. So 8051, 8052, EA which is connected to the VCC, and 8031 and 8032, EA which is connected to the ground. Okay, this is very important point. 805152 which is connected to the supply VCC, and 3132 which is connected to the ground. Next is PSEN pin. What it means? It means the program store enable. This pin is mainly used in 8031 systems. It is an output pin and it is connected to the output pin of external ROM. That is OE pin of external ROM. When the microcontroller wants to read program instruction from external ROM, PSEN becomes active. Okay, you know that, you know the short meaning of that. When the microcontroller, I will repeat the same thing. When the microcontroller wants to read the program instruction from the external ROM, PSEN becomes active. Only if PSEN becomes active, we can read the program from the external ROM. Next one is ALE pin. What does mean by ALE? A for address, L for latch, and E for enable. That is address latch enable. In the 8031, the port 0 is shared for both address and data to save pins. So how does the system separate them? This is done using ALE pin. External latch IC, that is 74LS373. This ALE helps to separate address and data during external memory access. Next one is input output port pins. This 8051 has 4 input output ports, that is P0, P1, P2, and P3. Each port has a 8 pins. So total 8 into 4, 32. So total 32 input output lines. After reset, all ports are configured as output, but they can also be used as input also. Port 3 pins have special functions like interrupts, serial communication, and timers. So, for practical understanding, we all know about that lab experiment. Although also we are having the LED blinking, switch interfacing, serial communication. These pins we discussed today are used practically. Definitely, if we are doing the lab, these pins function will help you. And you also visualize the connection. Okay. What are the topics we have seen? To summarize, we learned the history of the 8051, different 8051 variants, important pins like XTAL, reset, EA, PSEN, ALE, and input output ports. In the next video, we will move to programming concepts and applications. And thank you. Thank you for watching.